Yeah, I'm out of Hamilton, just had organic chemistry. Trying to work on Wyley, but I'm more confused than ever.
Let's start out with some basics, so brush your thoughts aside, and I'll tell you what I know. From ketones to aldehydes, let's start with naming compounds, going systematic. I know the common names, but I'm an IUPAC fanatic. Locate the parent chain, the longest chain of carbons, identify substituents. Here's some common jargon: methyl, ethyl, propyl, that's 1, 2, and 3. Butyl, pentyl, hexyl, 4, 5, 6. Are you still with me? Hepty, Octyl, Nonyl. 10 carbons is decyl.
Don't forget the rules about naming alphabetical. Number the parent chain, assign the substituents. The lowest always comes first. Don't be so ignorant.
And if you have multiple, use ditri or tetra.
I think I understand now, I'm so glad I met ya.
O-CHEM, carbon bonds are what things are made of, with reactions you can do. Now you're in O-CHEM. These mechanisms may challenge you, but TAs will inspire you. Now you're in O-CHEM, O-CHEM, O-CHEM.
Get ready values to compare acidity. Higher means more basic, lower is more acidity.
Let's talk about stability of conjugate bases. Look at how simple REO can make.
A stands for atom. We find which one the charge is on. A charge is more stable, gives a more acidic proton.
Resonance comes second, and if resonance is present, the charge is more stabilized, and this is very relevant.
I stands for induction.
I'll tell you about its function. Withdraws electron density, more stable is the assumption.
Lastly, O is orbital. These functions help us label. If a compound's more acidic, its base is more stable. Now when comparing bases, there's a few exceptions, like the solvating effect that I forgot to mention. Bulk increases pKa like methyl groups on branches.
I think I understand this now, I'm totally ecstatic.
O-CHEM, carbon bonds are what things are made of, with reactions you can do. Now you're in O-CHEM. These mechanisms might challenge you, but TAs will inspire you. Now you're in O-CHEM, O-CHEM, O-CHEM.
Let's talk about functional groups, like an alkyl halide. That could be a carbon chain connected to an iodine. Alkene means a double bond, alkyne means a triple bond. When it comes to alcohol, you just throw an OH on. Then we have an ether group where O sits in the middle, and aromatic compounds are never very brittle. Ketones have an oxygen double bonded to a carbon chain. Amines have a nitrogen in between 3 other things, and carboxylic acid. That group is a classic, and hydrides have 3 oxygens. These are not sporadic. Amides are only amines, except for the oxygen. Nitriles have a carbon triple bonded to a nitrogen. Then we've got epoxides. Don't forget the aldehydes, followed by an S in the middle of a sulfide. Finish up with ester, carbon and 2 oxygens. Someone bring the chorus back. Alright, here we go again.
O-CHEM, carbon bonds are what things are made of, with reactions you can do. Now you're in O-CHEM. These mechanisms might challenge you, but TAs will inspire you. Now you're in O-CHEM, O-CHEM, O-CHEM.
Compilability, designate priority. Based on the mass, then count 1 to 4 for me.
Counterclock is S, while clockwise is R. But remember to reverse it if the hydrogen's not far.
And if you need a tiebreaker, move to the next atom.
We know there's A's out there, now it's time